In a few moments, we will be taking you to a roundtable discussion. This time, we will be hearing about Advanced Air Mobility, or AAM. AAM uses new aviation modalities and technologies to transport people, deliver cargo, or provide services that support the public interest, such as emergency response and communication infrastructure. AAM has the potential to expand mobility and connectivity across urban and rural areas. The AAM industry is building on innovations like increased automation and AI, third-party services, and new sensing and computational techniques. Enabling AAM will require evolution across the aviation ecosystem: the vehicle, the airspace, the infrastructure, the regulations, and the community, just to name a few. Moderating our roundtable this afternoon will be Dr. Kelly Hashemi, who works at the NASA Ames Research Center in Mountain View, California. But before we turn it over to Kelly and her guests, let's take a quick look at some AAM-related research in action with this brief video on Data and Reasoning Fabric, or DNRF.
NASA's work to revolutionize the future of aviation often starts with a what if. What if we can fly safer, faster, longer? At NASA, our Convergent Aeronautics Solutions team, or CAS, apply innovation and curiosity to explore the what ifs.
I'm Ken Freeman, and I lead a research team at NASA's Ames Research Center in Silicon Valley. Our researchers talk a lot about what will happen in the airspace if there are lots of flying cars. What's needed to support this? What's needed to ensure that the skies are safe? It may sound like science fiction, but the advances in air mobility development make that what if possible very soon. As flying vehicles become reality, thousands of decisions must be made in real time to ensure the safety of passengers and people nearby. Decision-making comes from vital information such as weather conditions, travelers, cargo, and even ground infrastructure. This data, though, comes from different sources, and it can be hard to access.
I'm Supreet Kaur, an engineer working with Ken on the NASA Ames research team. We work to develop an ecosystem which hosts multiple forms of data from multiple sources called the Data and Reasoning Fabric, or DRF. DRF will connect information providers and government organizations to allow a quick and secure exchange with interpretation of the information necessary to support a safe environment as the airspace becomes more populated. Data and Reasoning Fabric will allow thousands of vehicles to adapt to the current situation, ensuring the safest environment in the air regardless of changing conditions, while also reducing the negative impacts on the environment with electric vehicles.
This can mean more travel options, fewer delays, based on the reduced transit times. Early testing stages for DRF also shows potential safety and efficiency benefits for missions like medical package delivery and even wildfire detection.
Researchers are discovering Data and Reasoning Fabric can have multiple technology applications, even in space exploration. Data and Reasoning Fabric is supported by CAS. To learn more about Data and Reasoning Fabric and other CAS projects, visit www.nasa.gov/CAS or scan the QR code.
All right, good afternoon. Thank you for joining me. I'm Kelly Hashemi, and I currently support the Airspace Operations and Safety Program, one of the areas we work at in NASA Aeronautics. And today I'd like to have a conversation around advanced air mobility, AAM, and the range of use cases and missions that might imply. I think we need to have a discussion around what it's going to take to make AAM a reality and focus a little bit on the innovations that we see coming that are going to help us make that change to this future aviation vision. So I will bring my panel on with me now. I have Wendy Okolo, Ian Levitt, and Karen Fye. And I'm not going to try to introduce them. I will hand it over to them to do their own introductions. Maybe let's start with Ian.
Hi, Kelly. Hi, everybody. Ian Levitt. I'm with NASA's Air Mobility Pathfinder project. Our mission is focused on part of AAM called urban air mobility, which is sort of the shorter haul operations in the urban environment and urban periphery. Our mission is to try to help safely accelerate these, what we call UAM operations, to scale through also what we call midterm operations. So past the onesies and twosies and into really gain a benefit from the concepts and the innovations that are associated with it. My role is leading the operational concepts, architectures, and requirements integration team. We're working to define sort of an overarching reference architecture for UAM operations that touches on the entire system of systems, and we use that to demonstrate how solutions can be derived out of a reference architecture, and use the results that we get from those demonstrations to validate and mature the overarching requirements. Our litmus test for whether we're successful is that everyone in the UAM community should be able to see themselves in the architecture that we describe, and that we should be able to clearly identify where the gaps are. No one of us can do it all, and our hope is that the work that we do and the framework that we put together to sort of capture it all provides valuable lessons learned to the community, and that it leads to a common architecture that the community can use to reference and work together more efficiently and effectively.
Thank you, Ian. How about we hand it over to Karen?
Hello, everyone. My name is Karen Fye. I'm a professor in the School of Aerospace Engineering at Georgia Tech. I am a cognitive systems engineer, which means I am very interested in asking the question, how do we get the most out of our humans? When we put humans in all these safety critical places, there's usually a reason we still have humans there. And so we really want to ask the question, what's the best use of a human to take advantage of their creativity, their vitality, and their determination that nothing bad happens on their watch, while also mitigating the fact that humans have limitations. We have memory limitations, we have vigilance limitations, and that has to be taken into account. So really asking these questions about where do we put humans in these systems, how do we put humans in the systems, what do we ask of them, and what makes a good combination of these types of things, humans working with technology.
All right, thank you, Karen. And Wendy.
Hello, everyone. My name is Wendy Okolo, and I am an aerospace research engineer at NASA Ames Research Center in California, even though I work remotely out of Houston these days. But I'm also the associate project manager for NASA System-Wide Safety Project, a project that is under the Airspace and Operations and Safety Program, AOSP, within NASA. And within the System-Wide Safety Project, what we're really focused on is how the changes to the airspace, how the aerospace industry and aviation modernization will impact safety. So looking at autonomous air vehicles, as small as drones that could potentially deliver your pizza, to air taxis, potentially that could take someone from downtown of a city to an airport. And when these new vehicle types, designs, and operations are introduced into the airspace, what does that mean for safety? For people, for the people in these vehicles, for the airspace, and even for our commercial, traditional, piloted aircraft operations, right? So what is that interplay between them? So we want to look at maintaining safety of our already really, really, really safe national airspace system, but look at how we can improve and modernize it from the standpoint of safety such that we are not reacting to safety incidents. And we're able to proactively identify risks and hazards to safety for vehicles as small as these small UAVs to really, really large aircraft. So we're really focused on the development of an in-time aviation safety management system, which takes our airspace from something that is more proactive, more reactive in terms of safety and the identification of risks and hazards, to something that is more predictive and mitigative, so that we can remove potential incidents of safety hazards and risks before they occur. So when you introduce these new vehicles, how do you identify the unknown unknowns that could potentially pose risk to safety, and how can you mitigate them in time before something bad happens?
All right, thank you, Wendy. And I'll remind everyone that I'm going to leave some time at the end of this panel to take some questions. So please use the Conference.io tool, and I'll be watching that as our conversation progresses here. But let's set some context to get started. Why do we want AAM? What good are these emerging operations going to do for us? Or what problems are they going to solve? So I'll leave that open. Who wants to take a stab at it first?
I can go. I can go. I think the benefits are vast, and because of how wide ranging what AAM is considered to be, I mean, the potential is just really vast. If we can achieve this and bring this to fruition, understanding that it's a partnership, right? From being able to assess fires, right? We're talking about wildland firefighting where it may not be safe to put a human right in that loop, or in certain situations like Karen was saying, where do you put a human when you take them out, right? Understanding that and knowing that you can work more efficiently, work significantly better, and work more safely if you have autonomous operations that are helping guide and inform the humans of where to go. To agriculture and being able to um, water and help farmers all over the world increase their crop yields, being able to spray insecticides at the right time, being able to understand when to irrigate, when to water, your crops and crop yield, and improve crop yield. To air taxi, regional air mobility and air taxi that can um, help alleviate the issues that we have currently with transportation and traffic. If you live in a traffic city, like I do, ultimately in the future, right, we can potentially improve our transportation system the way we do it now. And to emergency medical relief, being able to take people to hospitals sooner, being able to provide that kind of emergency evacuation, right, in terms of maybe even a hurricane, right, hurricane relief and disaster recovery, things like that. So because of how vast I think, the term AAM is and the umbrella that it covers, the potential is really endless. And I'll leave it to my co-panelists to add some more.
Yeah, I will say like some of for most of human history, we have been a terrestrial species, right? We have not been able to leave. And then if you think back just even 100 years to what we can do now in terms of connectivity, like where we can get, how fast we can get there, and what that means for both commerce, but also just human connection and interaction with each other, is absolutely fascinating. And so to take this up with AAM basically means that instead of having just one of these modes, which is very equivalent to having that old steam liner that people used to take across oceans, that's our only real option now. I mean, very few people get to take a helicopter, personal transportation, but to open that up so that many, many more people could do that. And the impacts on commerce, on agriculture, on healthcare. In Georgia, where I live, we have rural healthcare issues, right? We don't have the medical professionals in the places where we have people with needs. And if you could have a doctor get on board one of these aircraft on a Monday morning and get out to where they need to go and to run a clinic for the day and to come back and have dinner with their family that night, I mean, that is huge. And of course, there's the whole agricultural thing, right? So what if we could reduce our pesticides because we could be much more strategic in its application? What if we could move packages without putting extra people or on the ground? And in my city, like, we love the Amazon people, but they often block lanes of traffic. So worst time. So to have instead of having this huge truck like blocking lanes of traffic, there's just like this little spider-like little guy comes on in, drops the package, flies away, and 2 minutes later you never knew they were there.
Great comments. I mean, what Wendy highlighted some really fantastic use cases. And, I'll reemphasize what Karen said. Aviation has the potential to really transform society, right? As evidenced in the past. And I kind of see AAM as just, part of the transformation that we see globally across all sectors. I mean, it's, there's a digital transformation happening at the same time, some serious challenges, right, to overcome. So I welcome it because I think that it's a key solution to some of those challenges.
I know that's something that I'll probably emphasize later on in our discussion, but just the potential for expanded connectivity, aviation being accessible to a much larger percentage of the population because we have these variable types of modalities in aviation accessible to us. I think that could really change our relationship to this third dimension of transportation. Okay, so meaty question here. What kind of innovations are in the works that are going to allow AAM to happen or are going to really change the way that our progress towards this AAM vision is progressing?
I'll let someone else go first.
I'll roll with it because I think it kind of segues off of what I was saying. You know, like there's advancement across society. You know, with the advent of artificial intelligence, right? That's on the tip of everybody's tongue. But like the video that we saw just opening up this roundtable, right? And the potential for connectivity and what you can do with that. You know, as humans, I mean, it's our nature to find these solutions and then do like really, you know, incredible things with them. Hopefully, you know, if we're wise about it. So I, you know, my cheap answer is everything, right, across the board. Obviously, there are, you know, specifics to the aviation industry that are, you know, promising and, you know, kind of taking, you know, warranting a lot of attention, like electrification and hydrogen and, you know, just the simple thing that you get from, oh, it's electric, now it's quiet, now that unlocks so many things, right? It's these little things lead to really, you know, huge potential. That's what's kind of interesting. If I were to highlight one, I would actually point to the digital transformation of our research capabilities, if that makes any sense. I mean, if you pay attention to the transformation of the system is going to be ongoing, right? We're not building one thing, putting it out there, and then sitting back and enjoying it. It's going to be evolving continuously. And so how do we do that quickly? How do we make sure that the choices we're making are wise and propagate through the system well, and then we have a good, healthy evolution of the system? You know, if you look at some of like the digital engineering capabilities that are out there that are, you know, advancing very, very quickly, you look at, you know, F1 racing as an example. I think that's going to be, maybe it's kind of like, you know, not one of the more obvious choices, but getting ourselves to the point where we have really robust research to production processes that move quickly and safely so that you're not skipping over any, you know, potential tripwires on the safety side of things is going to be critical.
I'll talk a little bit, picking up on Ian's thing. I think we can't say enough about electrification. It's going to hit so many different areas, right? And I think people may not be aware of in the general public, like when you can have batteries, you can now run motors. Motors are different than engines. They're a lot smaller. You can put them in a lot more places. And other than the fact that the cabling is going to be very heavy, it opens up a lot more possible configurations for how you can make these different aircraft. And it makes it possible to have a lot more different motors than you would have an engine. Most small aircraft are going to have one engine because the engine is complicated, it's heavy, and it needs to be in a certain place. If you have motors, you can put them a lot of different places. You can have a lot of different ones of them. You can lose several of them with still having redundancy. And so there's a lot of really interesting things there, from really tiny aircraft. I mean, we're talking things that can fit in the palm of your hand, all the way up to really large aircraft that we're seeing in some of these very innovative spaces. And a lot of goes into that, right? So there's the battery chemistry, there's all of the motor design and the prop design that goes into that kind of thing. There's the gearing, and then there's all of the manufacturing techniques, as well as the new materials that are lightweight and optimized to be on these vehicles. It's really impressive how much innovation is happening in the past 10 years that I have seen that was not happening before that. And a lot of it is driven by these new use cases and by this new propulsive technologies and energy options.
I agree wholly and completely, and I don't have much to add. What I just want to say is, with aviation, having that potential really to transform the world. All of these technologies will have applicability to very, very different sectors, right? So when you think about that continued digitization and new ways to process the large amounts of data that we'll be getting, you can imagine the potential impact in like healthcare and being able to use, I mean, AI ML tools that were developed for autonomous vehicles to sift through large amounts of data and identify patterns and potentially even create solutions that that we hadn't seen before in other industries. So there's I mean, it's an exciting time, right, to be alive, and there's so much going on within this field. Sometimes we just start out with a blank slate, right? I talked about safety and the identification of risks and hazards, and our researchers would just start out with a really blank slate and try to imagine what could go wrong if they pictured literally, that's what they do. What could go wrong if I imagine this vehicle going from A to point B, following these waypoints? What are all the things that could go wrong, and how can I predict, model them early enough, and then potentially mitigate them, right? If I'm flying between these two buildings, there's a chance that I could lose GPS. And then if I can lose GPS signal, then what are my backups, right? What are the alternatives? What are the alternatives to global positioning systems that I can use? What kind of triangulation can I do? What kind of vision-based, you just start out trying to solve these very, very futuristic problems and come up with solutions that benefit various industries. So it's great. There's a lot going on, and there's still, I'm sure a bit more to be done. So yeah.
And I will say also, I think there's a lot of convergence here. So I think a lot of the challenges that are faced or are required to be solved to make AAM a possibility are not unique to AAM, right? So there's a lot of technology coming from the auto industry, right? They're trying to learn how to do self-driving cars, which is a little bit simpler than a self-flying aircraft in some ways, and it's much harder in other ways, right? So last time I knew, the GDOT did not put up, random cones in the airspace. They just asked the drivers to go around them, right? There were no sinkholes that they had to work around or random construction zones. But in other ways, it's much harder because you have three-dimensional space to deal with. You have winds, and you can't just stop if things go wrong, right? That's bad. But I see this coming from the energy sector. I see it coming from other forms of transportation. I see it coming from warehousing and logistics. A lot of the types of problems that we face, a lot of people are facing similar ones. And so there's a lot of crossover that can happen.
Speaking of crossover, I mean, coming from my background, we see new modalities for how humans are going to interact with increasingly automated systems. And this is very much coming into play with a lot of the different AAM use cases and missions that are trying to make a business case at this point. I also think, kind of on the more specific aviation side, there are some airspace design changes that the AAM industry are prompting. For example, we're looking at ways of how do we increase the use of third-party services, because we can't expect the FAA to provide the same level of services to this increasing number of operations. Or we're looking at what can we do to enable integrated access for a bunch of heterogeneous types of activities going on in the same space. And so I think changes like that are definitely going to be a part of the conversation as AEM becomes more mature. Okay, I have a related question for you though. What do you think that we're not talking about right now? We listed some innovations. What innovations did we not talk about that are going to be necessary for us to make real progress?
I think that there's some opportunity in different spaces that I think could help. For one, that kind of interaction and cosplay between commercial aviation operations and AAM. So we tend to look at them as these two kind of separate piloted versus unpiloted vehicle operations, and it's not just black and white, right? And even with the design and the full implementation of AAM as we envision it to be, there's a lot in between completely unpiloted and a piloted, operation, right? Where you have remotely piloted. So what does that look like? I think we could spend some more time understanding the implications of what our airspace would be when we start to have these interactions, because currently the airspace is predicated on a World War II era where you have this limited use for aviation, commercial aviation piloted operations, but the airspace has so much more. And if we you know don't split it the way we do, if we start to utilize it more, then we're going to have some more of those interactions. And what do they look like, right? What does it look like when a pilot flying a plane with however many 100 people is flying in a similar airspace as an unpiloted aircraft, and how do we divvy up those spaces? So looking at those interactions, I think there's some more that we could be doing in terms of that. We're doing a lot with vehicle design and creation and looking at which of those are really feasible, right? There's a lot of very interesting vehicle designs and understand the feasibility and the limitations in bringing those to scale, right, to market, and potentially even engaging the community a little more. And we do quite a bit of that engagement with standards organizations and the like, but the community, the people that know nothing about AAM and what that will mean for them, yeah, those are just a couple.
One of the ones that I worry about a little bit is sensor integration and sensor redundancy, particularly differential sensor redundancy. A lot of these new vehicles and capabilities are predicated on us having really great sensors and really great understanding of what's happening in the airspace and on the vehicle. And I think because we will start not having separate differential sensors as in humans on some of these vehicles, we need to make sure that if those vehicles lose key sensors, that they have a safe degradation pathway, that they have secondary sensors that you can deal with. So that's one I think we haven't talked a lot about. I think Wendy mentioned a little bit just starting to talk to communities that have traditionally been underserved by aviation as to what aviation might mean to them and what level of importance do they want to give to it or not give to it. I mean, I think we're going to have an interesting set of deep questions about what we prioritize and what we value, because right now we prioritize commercial aviation 110%. And it makes sense right now because that's probably 99% of all the air traffic, humans being served by aviation. But if we start to have these little guys and we start to have these medium folks, and when do we prioritize a medical transit over a big commercial aircraft? I don't know. I don't know the answer to any of these, and I don't think that there is an answer.
Yeah.
I think there's lots of conversations and a lot of context and a lot of thinking and going back and forth on this. But what we don't want to have is a whole set of communities that continue to be underserved by aviation, or bear the brunt of some parts of aviation with not getting the benefits of it.
I think related to something Karen said, though, we're also not talking about the system of systems conversation enough. I think that, we're talking about having autonomy that exists at multiple layers, from the aircraft level, airspace level, on the side of our services. There's a multimodal transportation question that represents our transportation ecosystem that we don't talk about a whole lot. We have the opportunity potentially to utilize not just the vehicle as our degree of freedom and the operations the vehicle are doing, but also like the environment we put it in, the tasks we ask it to do, and collectively can we construct something that achieves those good things we talked about at the beginning of the panel.
Kelly, that's a great point. I actually just want to add something about that system of systems interaction. I mean, even from the perspective of safety, what does a failure in this motor mean, for the entire electric powertrain? What does it mean for the vehicle? What does it mean for potentially mitigative action? And what does that action mean for other aircraft and the national airspace as a whole? Because it is a system of systems that you must keep safe, right? right? It's not just this one component or this one system. It is a system of systems. And overall, you want to maintain efficiency. You want to maintain safety. And like Karen said, how do you prioritize A over B? So that system of systems interplay is critical. We are doing a little bit of it, but I think there is more as well. And Ian, I think Ian, you were gonna go.
Well, I mean, just really doubling down on what everybody's saying. I mean, system of systems. I mean, that's my day job. The reason why we're doing, the architecture and having it cover the entire system of systems is because the complex environment. If I were to vote on, what we aren't talking about enough, I think is probably the lessons learned from ATM from the last 100 years of evolution of the system. There's a lot of, I've seen too many concepts fall apart when we add wins to the test environment. And now that we have, it's not a clean sheet design, but we're starting a little bit from the beginning here, and we can really we can avoid a lot of the relearning a lot of those lessons if we talk about it more.
I'll say one more thing, is that I tend to think that our current systems are underspecified. As in, there's a lot of things that air traffic controllers and pilots do because they know the goal in mind, right? And they just make it happen. And they're not ever told specifically. There's not like this set of very specific rules that they apply rigidly all the time. They're constantly taking their training and their rules and deciding, does it apply now, or do I have to break these rules? And I haven't seen enough of that to have a lot of confidence in how we start automating the things that I think are going to need to be automated to scale up. And it worries me a little bit. I mean, I've seen tests before where I've been in air traffic control facilities and they've got a new tool and we just see them overriding the tool. And we're like, why did you override the tool? And they're like, well, if we didn't override the tool, then the planes would get too close together. We're like, okay, but why didn't you tell us that you had to override this new tool? And they're like, I don't know, it's just our job. It's just what we do, right? They didn't even think to mention it, even though it was a new tool that we were asking them to try out. And so I feel like there's a lot of things like that. Like I heard an NPR story just yesterday about some pilot who flies with sticky notes, right, to remind him of technological limitations on the aircraft that he's flying. And I was like, yeah, so that kind of thing, also an underspecification. So I worry that we have all of these systems right now, which are held together with human glue, with human, training and human, just thought processes and common sense, really. And we take that away, do we have the specifications well written enough to handle all of these, cases, both nominal and off nominal?
All right. I'm going to give you one last question here to the panel, and then I'm going to start flipping through questions we've gotten from our listeners. Okay. So a point I want to make is that I think enabling AAM is really going to take a whole ecosystem conversation. I'd like to plant the seed that it's not just a technology problem. It's broader than that. It's going to require changes to our infrastructure, to services, to the operators in the AAM future world, regulations, community acceptance. So tell me about how what you're doing fits into that ecosystem approach to the changes we need to see to enable AAM, or tell me about what's not happening in the ecosystem or that you need to see happen in the ecosystem to allow your piece to be successful.
I mean, I would start with, I think that, because mine might be a little bit of an outlier, in that, I think the goal that, my project and my team is pursuing is to try to catalyze the ecosystem, by providing a reference point or an architect, and the sort of an architectural structure that can have folks who have a more discrete answer to that question find the place to stick to put it, right, and find the people to talk to and coordinate with and get the right assumptions so that they can solve their problem and have it actually integrate, right? I mean, we all have to be roughly leaning in the same direction. Otherwise, it's just going to be kind of a struggle.
Yeah, I can go. I think so. The work that we do informs standards organizations. We're very plugged in with various standards organizations based on the results of the research that work would do, so that we can inform, potentially regulations and things like that. The ecosystem that we are also involved in includes universities through university-led initiatives, working with various universities who are also partnering with other members of industry to bring some of their work to fruition that supports AAM. We have a lot of opportunities to disseminate our work with different organizations at conferences such as the IAA, and even from an international perspective as well, because I know imaginAviation has I saw a record-breaking 83 different countries watching, imaginAviation over the 3-day span, and I'm like, wow, we work with different international agencies and organizations and standards organizations as well, such as ICAO, IFAR, and a number of others to really enable and bring this ecosystem to fruition. However, in terms of the opportunities that I see to enable some of our work, I think really just the openness. Karen said, you brought up this example of the tool that was, presented to the FAA air traffic controllers, and they're like, yeah, I'm just going to go ahead and override it and go with what I know, versus there being this loop that's being closed, in that the tool is not applicable, it is not adequate, it is not sufficient in this regime, so that the developers of the tool can go back and make some modifications. So sometimes we're not able to close that loop. Sometimes we're not able to get all of the information we need. I mean, and when I say information, I'm talking as basic as CLCD data, basic aerodynamic information from the OEMs, from the original, equipment manufacturers that can feed the work that we're doing to inform the regulations and the standards, right, for design, certification, and operations for these vehicles. So some of that openness, some of that closing that loop, and this is what we see, this is what we have, here's the information we can provide to you, so you can inform and potentially make our tools better. There could be some more of that within the ecosystem, but there is some talking, but we could be talking a little more. Yeah.
I have to say, I'm not in AAM 100% of the time, right? As a university professor, I don't have the luxury of some of that, but I do think that I'd like to start seeing some of these test beds really start to play around with things. Because I think we have to assume that we're going to fail a lot before we're going to succeed. And I think that working through some of these things, the way to do it is to set up some airspace somewhere and try not to hurt anybody and give it a bit of a go. To my mind, I feel like we've been studying this for a long time. I haven't seen a lot of real, obviously tangible results. I see a lot of individual companies making a lot of pushes in their own direction. I feel like there's a lot of spikiness, which is great. But for these companies, I feel for them, because they're putting products out there with the hope that there will be an ecosystem to plug into when they're ready. And if the ecosystem is not there here, I worry that there will be an ecosystem available somewhere else that they would try to go to instead, which will leave the US system a little bit behind and lesser for it. Or that they will just stop doing it at the end, right? It will just be one of these things like we didn't make progress enough, so therefore we can't do certain things here. So I think we need to make sure that we've got all these people pushing certain technologies forward kind of coming together. I think that this kind of conference is a great starting point, and I'm sure that there are other in the regulatory RTCA and different things. I hope that all those folks are sitting around the table, because I feel like they've got a vision. They're trying to move forward with it. They've really put their money where their mouth is, and they're working 100% time to make it happen. And I really hope they succeed. But I worry a little bit right now because I'm not seeing some of the underlying infrastructure come through that in a way that, in an obvious way, like in an overt way. It may be happening behind the scenes and it may be quiet, which is fine. But as an external observer to AAM, a lot of the time, it seems like air traffic control doesn't operate much differently than it did 20 years ago. And I'm not hearing things about how we integrate current air traffic management with new novel things, with digital relays and that kind of thing. So I don't know if all the architecture that Ian's doing and all the system-wide safety that Wendy is doing, is anyone picking it up? Right? We're just doing this work and then nobody's running with it on the other end. I don't know.
I agree. I mean, the learning by doing part, I mean, that's how you close the loop quickly, right? That Wendy was kind of talking about.
Right, right. And we do have some technology transfer, but you're right, that ecosystem must be there. I also want to add a caveat that these companies that are creating these vehicles and looking to an ecosystem to be there for when they put out their work need to realize that they are part of that ecosystem. They are a huge part of that ecosystem. So it's not this external, we're developing the technology and we need the ecosystem to be there. They're part of the ecosystem and the ecosystem needs them to share. To share.
They're actually just going to create their own ecosystem. If there's not one there, they're just going to be like, okay, we're just going to make this. And then all of the work, not all of the work, but perhaps some of the work that's been done, Wendy is like, we definitely shouldn't do A, B, and C. We know that that's been a lot of research. We know that that's bad. And then all of a sudden somebody comes along, they're like, here's our new ecosystem. It includes A. And Wendy's like, oh God, it's not A. That was not a good idea. And I just, I worry that there's this, talking like this, right?
Right.
All right. I think maybe we have 5 more minutes here. And there's a good question. You ready? On the top of our question list here. So I'll read it to you. How can UAM avoid worsening the massive inequality in transportation that exists today and not only benefit the top 1% to 5% earners?
It's an excellent question. And I think I just want to preface this by saying AAM as it is more than air taxis for rich people.
Yeah, I think that's
it
important
is.
to note,
It's
that it's
more,
not just
yeah. It's not just air taxis for rich people. It is getting someone that's been critically injured sooner to, quicker to a hospital. It is evacuating people that are, stuck in disaster areas, and it is getting bags of, medical supplies to remote areas. So AAM will hopefully make a more equitable society for us all.
There's a risk though, right? I mean, if you look historically at just like what the transportation system is capable of doing, right? I mean, it's not only does it, contribute what it does to global climate change, but it's an enabler for so many things to change. And there's lots, there's history where it does not necessarily push us in the right direction. So I totally agree with you. Like that's what it is, but we got to keep that risk front and center. And there's a lot of ways to do that. I think, like a really rich public-private model so that everybody's voices are heard. Great transparency in the discussion so that, you allow both. I mean, products are gonna succeed, right? If there's a need for them, but how do we also take that momentum and use it to nudge the whole system for the benefit of all of society? It's a tough problem.
I will say that often the initial risk and cost for new systems is borne out by a lot of rich folks, right? I mean, how many space tourists do you know that, make a normal salary, right? But eventually, usually those risks come down. We lost a lot of people in the early days of aviation who paid an enormous amount of money for their tickets. right? We did. But yet now we have one of the more safest forms of transportation that we have. We can get cheaper tickets. I mean, air transportation is much, much more accessible than it ever was in the early 20th century. So I want to say that it wouldn't kill the whole system if in the first several years it does look like that, because I feel like we are going to get beyond it. And it historically, if you just look at all forms of transportation, it has this weird hump, right? It's going to be unequal at first, very unequal at first. Probably, I can't imagine it not being. I don't want to say that it's just reality, but I do think that it is a temporary hump that we get over. And I would, all these things that Wendy was talking about, she's so right? We want to be able, imagine if we had self-flying taxis. You could pre-position those in a lot of rural areas because you don't have to have a pilot and a crew ready to go in the moment's notice, right? And we could deploy them much faster than we could anywhere else. Again, you can get doctors from population zones. You could have them run clinics, in ways that we couldn't do before. I think that there's a lot of capability here, and then that there's going to be some exacerbation early on. I have no doubt in the inequality, but I hope very quickly that hump will come down.
And I'll put a plug in here for NASA that I think that as a public agency, it can be part of our role to support, the very visible part, the UAM part, and the operators that are trying to be financially successful right now, build up this baby industry. We can be there to help make sure that the progress is serving these other potential missions that we want to encourage as well. All right, with that, I'm going to thank all my panel members. Thank you very much for joining me and having this conversation today. And I'm going to hand it back to you, Steve.